So today in this video we are starting the new chapter, that is gravitation. Okay, now see, generally the term gravity it means that basically that it is a force applied by earth on every object on earth's surface. Similarly on us also, right? Since due to gravity only we are able to walk, we are able to sit, we are able to run, because earth is pulling us towards its center. Otherwise we would not have the power or the capacity to walk, to sit, to run, nothing. Okay, so here the thing is that the first topic of this chapter is universal law of gravitation. Very important thing, universal law of gravitation. So the statement of this law is like this, that we considered here two bodies, this one and this one. They have some masses. The mass of this body is capital M, suppose, and the mass of this object is small m. They are separated by a small distance, which is not small distance, by a distance which is d. Okay, now here by the universal law of gravitation we state it, the statement is like this, that the force between two bodies is directly proportional to the product of the masses. Force or the gravitational force between two bodies is directly proportional to the product of the masses. That means F is directly proportional to capital M into small m. That's what is written here. Again, the statement has not finished here. Again, another part we have. The gravitational force is also proportional to 1 by d square. 1 by. So the thing we write it like this mathematically, F proportional to 1 by d square. We call it force is inversely proportional to distance square. Inversely, because it is 1 by. 1 by what? Distance. So we say that in the statement of universal law of gravitation we will say that the force between two bodies is directly proportional to the product of the masses, is inversely proportional to the square of the distance, and then combining these two. On combining these two, what we get? We are combining both these equations, this one and this one, we will get this. So F is proportional to this. Now remember that whenever this proportionality sign is removed by equal sign, we put a constant here, and in this case the constant is capital G. We call it universal, this one, it is called the universal gravitational constant. Okay, it has a particular value, that is 6.67 into 10 to the power minus 11, this one. G is equal to 6.66 or 67 into 10 to the power minus 11. Its unit is Newton meter square per kg square. Okay, so this is the statement. If you are asked that state universal law of gravitation, state, then we'll say you'll write in word that force between, or the gravitational force between two bodies is directly proportional to the product of the masses, inversely proportional to the square of the distance. Okay, this much. And mathematically means this one, first this one, then this one, and then this one, combining, and finally what we got, this one is the mathematical formula which says universal law of gravitation. Okay, and if you are asked to state, then you have to write in words. Alright, so now the value of G already I told you. Then here there is a sum, this one you can see. Okay, another thing, this inverse square means this is one line is written here saying that F is inversely proportional to the square of the distance d. Means, for example, okay, about this inverse square I will tell you, I will give you some examples. But this one inverse square means, just now I told you that gravitational force F is directly proportional to 1 by d square. So this is called inverse square. It is inverse, no, 1 by, and what? It is square also, d square. So this is the inverse square law actually. Okay. Anyways, let us see this sum. It is given that mass of earth is this much, mass of moon is this much, they are at a distance of this much kilometer. Calculate the force exerted by earth on moon. The value of G is given, this one, 6.7, 6.67, or it goes like that only, 6.666, like that. So approximately it can be 6.7 also, we can say, into 10 to the power minus 11 Newton meter square per kg square. So you are asked to find out the force. So just now we got the expression for force, it was this, right? Okay, suppose capital M, you consider it as the mass of earth, which is given in the question, this one. Substitute it here. This is the value of G, this is the value of mass of earth, this is the value of mass of moon, small m, and this is the distance of them, this much of square, because it is distance square. So for this type of sum, direct application of formula is enough, but the thing is that the calculation, okay, with the power. So for that, I mean for calculation, what we can do is all the power of 10 you put them together, means this is 10 to the power 8 and one square is there, so it becomes 10 to the power 16, and as it goes up it becomes 10 to the power minus 16. So first let us see 10 to the power minus 11, okay, minus 11, then 10 to the power 24, there is plus 24, then 10 to the power 22, so plus 22, and then this 16, it goes up, it becomes minus 16, so minus 16. This will be the power of 10. Okay, what it should be, 24 plus 22 gives us 46. 46 minus 16 gives us 30. 30 minus 11 gives us how much? It is 19. So the power is 10 to the power 19. Okay, we'll keep it like this. Then after that you do the rest calculation. This one into this one into this one, dividing it by this square, 3.84 square. If you do it, the value will come automatically, and whatever value you are getting, you write that. You don't have to match with this answer. This answer means, the reason is that here they have taken the power in 20. It's okay, we can keep it in 19 also, 10 to the power. So the power of 10 we got 19, you keep it like this. Okay, but the rest thing you have to do this one into this by this square. Alright, so the value that we will obtain, that will be in Newton. It is force, the unit of force is Newton. Okay, then here the question number 1 is, state the universal law of gravitation. Just now I told you the statement that the force of gravitation between two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Okay, this is a statement. Then write the formula to find the magnitude of gravitational force between earth and the object on the surface of earth, this one. So for this we have to take this one, okay, we can do it like this also. But you are asked to write the formula to find the magnitude of gravitational force between the earth and an object on the surface of earth. Okay, suppose this is earth, we have an object on the surface of earth. The mass of earth is capital M, this is the center of earth. This object is having a mass of small m. The distance between these two bodies are nearly equal to the radius of earth. Okay, so what will be the gravitational force now? The formula what we have, F gravitational force is equal to capital G, then it is capital M, small m, and the distance. Now the distance is nothing but it is the radius of earth, so capital R square. Okay, so this is the formula that you should write for question number 2. Okay, so okay, another thing, importance of the universal law of gravitation. These 4 points you remember. Okay, is given that the force that binds us to the earth. Obviously the universal law of gravitation is very important for everything, like due to this force only we are bound with earth. right? We are able to do all activities due to what? Due to gravitational force. Next one, the motion of moon around earth. Yes, motion of moon around earth is also due to gravitational force or due to universal law of gravitation. So these are the importance. Then the motion of planets around the sun. Of course, sun is pulling with its gravitational force all the planets in the solar system. Then the tides due to moon and the sun, high tides, low tides, this also takes place due to gravitational force. Okay, so this 4 points you remember this as the importance of universal law of gravitation. Okay, then in the next video we'll discuss about Kepler's laws and some extra things related to this inverse square law. Okay, thank you.